Hi and welcome to another Hopper language video. I had a recent request, a question like how would I embed some hex data in the source of a Hopper program. So I'm going to write a language video, which is really a bit of a cookbook to show how you would do this. So that's how you create a new file. If it doesn't exist and you open it and edit it, creates it. So we'll give it a name, program, embed, and there's a bug in the current Hopper editor in that it doesn't do syntax highlighting for a new file until I open it again. There we go. Now, I was thinking about how to implement this, and I could have implemented it using arrays as well, but for reasons related to making it work on all the platforms and optimization, it's easier to just quickly do it as a string, because arrays can have three different implementation. There's like a 1-bit arrays with an array of booleans, there's 8-bit array which is an array of bytes or chars, and then 16-bit array which is integers or uints. So just doing it into a string, they're always going to be 8 bits wide. So if I do this, let's build that and see what happens. Yes, so we've now got embedded data in our program. So if we go for each, how are we going to do this? Yeah, let's do for uint I equals 0, I is less than data dot length, I plus plus, and then we're going to just go print, let's go print data I, and let's put a space behind it. Yeah, let's put a space behind it. Let's see what this looks like now if I compile that. So immediately I start to run into very interesting compiler errors. Type mismatch uint, expected uint was nothing. So it's very confusing. And I think it's because it doesn't know what data length is, and it's expecting a uint here. So if I go users source system string, then if I look at system string, it's got the length method in here. So I think that's what was missing. It didn't know what length was, but let's find out if I'm wrong or not. So compile again. Now we've got, so yes, it was that. So system string was required. And you get all sorts of interesting errors like this. I'll show another one later, and then I'll show you a better way of doing this. So print was not defined. So this is not defined, and that's because it's actually screen.print. So if I do that, still not defined, and that's because I haven't included screen. So, and that's also in the system folder. There's a unit called screen. So if I look at screen, yeah, it's got prints and print lines and things defined. Right. So I've included screen. So now if I build this, if I look at the bottom of the screen, it's successfully built. And now if I say start without the debugger, nothing happens, right? And the reason is because it finishes faster than it actually does run very quickly, but you don't see the results. So if we go key equals read key here, now again we're going to get, and I can get rid of that message too. Key is a public identifier not available. Complicated error message that's not very clear what's wrong. But what's wrong is I haven't included keyboard, and keyboard is where key is defined. And now if I build, and then I can control F5, there we go, embedded data. So one of the other, and also if I make a change here, and then if I press F7 to build, it always offers me the save option. So I can do this save on build. Now it'll just, if I make a change, it'll just build without, and save and build, it won't prompt me. And at the same time, I can run the optimizer if I want to as well, but we don't need to do that. This is fine. So we can do that and then control F5. So the two keys I'm using are F7 to build and Control F5 to run. And now it's stopping, pausing on my key at the end, and if I press a key it comes back here. Okay, so we have some data embedded, but now let's make it into not text data, sort of. So we can say byte, make a byte from that character. And now instead of printing out the character, we can print byte to hex string 2. And again, this is going to fail. So if I build this, it doesn't know what that is. So, you know, it's expecting a comma here somewhere, doesn't know what this is. And the reason is because the 2 hex string is defined in the uint unit. But it's very cryptic when you've got system methods that don't exist. When you see that I did that wrong, so maybe it was defined in the byte unit because it's a byte 2 string. Let's try that. Yeah, success now. So now if I Control F5, I'm getting hex out. But an easier way to avoid all of these cryptic error messages would be just to include system in the beginning of pretty much all your programs you ever write. Just do system, because it includes all of the others. And then, you know, you compile, run, everything's good. Okay. So, when I chose to implement embedded hex data like this, like if you try to print out characters that are not printable, like 0, 1, etc., I mean hex values that are not printable, you wouldn't see them. So that's why I'm printing hex now. Let's go back to there. So for example, if I've got some, on the clipboard, I've got some hex data there. So now my data is truly hex. So let's build that. And then we run it again, and okay. Let's go, let's say here, after every, so if we go I mod 15 equals, I mod 16 equals 15. That'll be on every 16th character because it starts from 0. I think I've got this right. If I print a new line, what happens here? Yeah, so we've got a new line after every 16th one. And then we could add another thing here. It's not, I mean, it's very verbose, but you can kind of, it makes it easier to understand what I'm doing. So if on, let's say on every, after every 7th one, we're just going to print an extra space, after every 8th one, because it starts from 0. And we print an extra space. Let's see what that looks like. Yeah, so that now we've got a space in the middle here, so we can see what's going on. And how about on every 0th one we put the address? So over here, before the start of each line, we can do a print, and we can do I to hex string 4 plus a space. Put 2 spaces in there. Let's see what that looks like. So we've got a little hex dump of our data now, because we've got our addresses in hex on the left here. All right, so it's an interesting, an easy way to embed hex data into your program. So you might want, you know, like a bitmap, for example. That I came across this when I was trying to put bitmaps into the, you know, testing the display drivers. But then I got a request to say how would you do this for, you know, like if I want to embed 5K into my program. But you might not necessarily want to include it in the source. You might want to include it as a constant and use it in multiple different places. And then the optimizer will also, if it's not used, it'll exclude it. So we could do that. I made it work for constants as well. So let's have a look at how we would do that. So I've got it on the clipboard again. So if I paste in a big constant here, a big hex constant. So if it's over here, it'll get handled by the preprocessor, you know, compiled by the preprocessor. If it's down here, it'll get compiled by the compiler. So we can go, that's const data. I think that's what I called it. Yeah, const data. So let's try compiling that. Takes a little longer. And then we Control F5 that. And we have a much bigger chunk of embedded data. You could also use this to include it in another unit, or so that you can easily. So if I put this into a unit with my constant data and then a getter to get my constant data, it means I could machine generate that file without having to have it in my actual source file where the rest of my program is. Anyway, this is how you would embed some binary const data. So this has zeros in it. It has things that are not necessarily printable ASCII characters, and you can access your const data like this. Right. Thank you for watching. Look forward to your feedback in the comments. Let me know if there are other language videos that you think I should do next, or if this kind of style of cookbook video is working for you.